Hello, so in this video we're just going to be doing an introduction into the average rate of change. So the first thing that we're going to look at with the average rate of change is just the slope of a line, because a line doesn't change at all. So once you've found its slope, you found its average rate of change. So if you take two different points, and I'll just draw out the chart here for it. So here's our graph, and we're just going to mark out our two different points. You can see we've got the point 1, 2, and then we've got the point 5, 8. So I'll just mark them in here. You've got 1, 2, you just come across 1, and then you come up 2, and then across 5, and then up 8. So we're going to get our 2 points here, and these are 2 points on a line, so we can just draw a line straight through the two of these. And we'll call this one here, we'll call this point A. That'll be 1, 2, and then this will be B, the other one over here. Now, to find the slope of this line, using when you just get 2 points, you use the following formula. So it's going to be y2 minus y1 over x2 minus x1. So if you look up at your points here, we can just give them labels like so. So you call this x1, this will be x2, and this will be y1, and this will be y2. Now, it doesn't matter at all what way you could have called this y2, and you could have called this, or you could have called this x2, and you could have called this x1. This equation will work out the exact same. So we're going to just fill that in like so, and you'll get the slope of your line then. So the slope will be y2, so you just take 8, and then minus y1, minus, and then 2. So 8 minus 2 over 5 minus 1, so that's x2 minus x1. And then you'll end up getting 6 over 4, which we can simplify by just dividing by 2 on the top and the bottom. We get a slope of 3 over 2. So that's how much that's changing. It's kind of telling the steepness of that. And you'll notice that it's also a positive number, meaning that this is going up the way. So like in writing, the way we read left to right, if you go left to right with this and follow along, you'd see you're going to go up. So that's what that's going to be a that's going to be a positive slope moving up and down this direction here. Can I just note something that's important when we look at doing this for calculus questions as well? So this is your y-axis, and just to note that that is also known as your f of x. So f of x and y are just interchangeable terms, but f of x is one we'll need to understand for calculus. So it just means that if you were to take whatever this function and you put an x is equal to 1 in, you'll get the answer of f of x. So in this case, you'd get, if you put in 1, you'll get a 2, or if you put in a 5, you'll get an 8. So you'd see that probably more if you had the full equation. So now we'll just move down here and we'll try question B. I'll draw out the graph for that. So you can see I've another question drawn out here, so I can actually just do the line coming in between the two of them. And in this case, you're actually going to see that this line is moving down the way. So if you were moving left to right, you're going to go down. So we're actually going to expect a negative slope for this one. So we'll do out our same formula. So y2 minus y1 over x2. And actually, I'm going to change it this time. Instead of calling it y2 over y1, I'm going to change these symbols up here. And instead of y, they are y, but just to, there'll be a reason for this that we'll look at in future videos. We're actually going to call that f of x1. And then this is going to be f of x2. So now we're going to be left with this formula here. So we're going to get f of x1 or f of x2. It actually doesn't matter which one we put first. So we're going to get f of x2 minus f of x1. And then we're going to get x2 minus x1. So it mightn't be apparent why we're doing this at the moment, but there'll be a reason for this when we go on to future videos and we're looking at differentiation by first principles. So for this one here, we're going to get f of x2, which is going to be 1, and then minus f of x1, which is 7. And then we're going to get 6, so that's x2 minus x1, so that's 6 minus 2. So if we simplify that out, we go to our next line, equals 1 minus 7 is going to give us a minus 6. 6 minus 2 is going to give us 4. So if we break that down, you can see there's a negative on the top and a positive at the bottom. So this is going to end up being negative overall. So we're going to get negative and then divide the top by 3, or divide the top by 2 and you get 3. And then bottom by 2 and you'll get 2. So what you're doing is you're getting a change of 3 over 2 down in this direction. So the higher, the steeper this slope going down, the higher that number is. So if you get it one sloping down like this, you could end up getting a slope of 10, or if you go down further, it could be a slope of 100. Or for just the more steep it gets, the more bigger that number, meaning the rate of change, the rate of kind of decrease is going to be bigger. So in this next question, we're going to be looking at how can we begin to start getting sort of an approximation of what is the rate of change in different parts of this curve. So you can see that this, unlike the line which was just a straight line going up and down, which just didn't change at all, you can see that this is going to have different rates of change. So what I mean by that is that if you took this curve, and if I was to draw a tangent here, that would represent the rate of change at this exact point. So you can see this is changing rapidly down. And then when you come down to, say, point down towards this part here, you can see that the change is becoming more gradual. So you're going to have a different rate of change here. So if you wanted to think of this in terms of, say, a skateboarder going down a half pipe. So you've got your skateboarder there, and he's going down this direction. You can see that at the very, very start, he's going to be changing rapidly because he just hit the top of the half pipe and he's moving at a really fast speed. And as he gets down, he's going to actually slow down. I know you're going to be thinking with gravity, it'll speed up, but we're not talking about speed in this time. We're talking its change of position. So we're thinking from here, it's starting from a very high position and it's moving quickly into lower position till it's petering out, stopping in the middle where it's at its lowest position, and then it's going to go rapidly increase. So this part is going to be rapidly decreasing, and then this part is going to be rapidly increasing. So the way we're going to start approximating that is by finding the rate of change between 2 points. So say if we take point A and B and we find the rate of change between the two of them. So what I mean by that is if we were to draw a straight line coming straight from A to B, then the other one, so we're going to start off looking at A and B, and then after that we're going to look at C and D, and then we're going to look at E and F. So you can see that actually A and B is going to give us a pretty good, because it's so close to the curve, it's going to give us a pretty good approximation, but not an exact one, and that's what we'll be using. That's what we'll be using calculus to find the change at an exact point. But we'll just begin by looking at this. So if you take line A and B, and we'll put up our formula that we were looking at earlier. So I suppose first things first is we need to establish what point A and B. And now you can actually see it by the chart here. There's a -4 there and a 10. But if you weren't given them points, I want to actually just show you how you would find it at point A. And then I'm just going to after I've shown you one, I'm just going to fill the rest of them in. So this is our equation. So if you take any point, say if you want to find point A, we can take a point A, we're going to have x is equal to -4. So often they'll tell you that is just, they'll tell you what point we're trying to get it at. So we're usually going to start at x. So if you put -4 into this equation, you're going to find out what the y value is. So we're going to expect to get the value of 10, but I'm just going to show you how to work that out first of all. So if you want to get your first point, the first part of it will be -4. And then you're going to say f, and then just replace the middle with -4, and that just means you replace all of these x's with -4 as well. So -4 squared plus x minus 2. So we're going to do that out. -4 squared is going to give us 16 plus, and I actually made a mistake there, I should have filled my -4 into this part here as well. So you can see 16. And then plus -4, a plus by a minus is going to give us a -4 minus 2. And you can see if I do that all out, it's going to give me 10. So it's just giving me exactly what I can see from my chart. And I won't do the other ones. I just wanted to show the first example to show you how you get that. So that's going to give me my point, -4, 10. So that's my first one. Then b, which we can just read off the chart, is going to be -3 and then 4. B is -3 and 4. And I'll just put them up here now. So you can see I've just done out my points here, and then I also have my formula for my slope. So we'll just take the first one between A and B, and just remember that these ones, this will be x1, this will be x2, this will be f of x1, and this will be f of x2. And then just simply just fill them into our formula like so. So if we're doing it, m will be equal to, and we're going to take f of x2, so that's 4 minus 10. And like I said before, if you did 10 minus 4, f of x1 minus f of x2, this will also work. It'll be the same, the answer. So you can try that out yourself and see that. So 4 minus 10 over -3 minus -4. -3 minus, then we just need to put in our -4 there. So if we press that equal, 4 minus 10 is going to give us -6. And then -3 minus, our two minuses will come together to give us a plus. So it's going to end up -3 plus 4. So that gives us -6 over 3 minus 4, which is 1, which just gives us a slope of -6. So we'll just write in all our slopes as we're going along here and just see how the rate of change changes as we move along through this. So we'll do our next point now. So you can see this time we're actually going to look at the points from C to D. So for this one, we're going to have x1 is -2, x2 is 1, f of x1 is 0, and f of x2 is 0. So we'll just put them down into our formula. So we've got m, and in this case, it's going to be 0 minus 0 over 1 minus -2. 1 minus, and then we're just going to put -2 in here. So you can see 0 is going to stay on top, and then it doesn't really matter what's on the bottom. It's going to end up 0 anyways, but we'll say plus and a minus, and a minus gives us a plus. So that's going to give us 3 at the top. So it's actually a slope of 0. And you can see that's actually an important thing we're going to come across again. If you've got a line going along flat, it's going to be a slope of 0. So just as a side note, we will be looking at this again, but if you look at the very bottom of your curve there, we'll take a yellow to mark it in. If you were to do a line coming across there, that's going to give us a slope. So if we look at this point at the very, very bottom, that one there is going to have a slope of 0. And that'll be very, very important, because there's going to be times later on we want to find the maximum and minimum points, and we'll come across that then. So for our final one then, we're going to get m is equal to f of x2 minus f of x1, so that's going to be 10 minus 4 over 3 minus 2. And as you'd expect, because this one is going up the ways, we're going to end up getting a positive slope. And I'll put in my slope of 0 there. So 0 here, -6 here, and then this one is going to be 10 minus 4, which is going to give us 6 over 1. So we're getting a slope of +6. So you can see this one is decreasing. That's why it's symmetrical on either side. You can see these points. So this time it's increasing at a rate of 6, and this one it's increasing at a rate of -6. So so this one it's -6, and then this one is 6. So what we're going to be doing when we're doing calculus, what calculus does, it brings, say that point B, you can see that this is a pretty good approximation for the slope of that line. But when you come down, say, to point C, it's not really going to give you a good approximation of it, because if I was to do a tangent coming down along here, along by that line, you can see that it's got an entirely different slope to that 0. And then if you take that one coming up here, so you've got two different points. So if you want to find it at an exact point, what you can do, we'll discuss this more in subsequent videos, what you can do is if you bring D closer and closer and closer and closer and closer and as close as possible to C, you're eventually going to take, so say if you get, so say if you took a point D, you're going to get this approximation, which is 0, which is completely off that slope. But if you actually just move that closer and closer. So say if we picked a point here, closer to that still, and then we drew a line between here and here, you can see you're going to get a better approximation for that slope. So you'll get something that is a lot closer to that yellow slope which I'm looking at here, and the closer we're going to bring it, the better that approximation we're going to get. So we'll have a look at that. We're going to look at limits next, but after that then we'll go into more details of how we can come up with an equation to do this.